first topic in physics is measurement. So that's where everything starts. That's where physics starts from. So please, you have to make sure that you know that topic as well. So physics is the study of matter, energy, and their interactions. Physics is the study of matter, energy, and their interactions. Okay, so when we talk about physics, it deals with physical quantities and motion of matter. So we are saying that physics deals with physical quantities and motions of matter. So now, since it deals with physical quantities, then we are going to look at physical quantities. Okay, so physical quantity, it is a quantity that can be measured. So anything that can be measured using the instrument that you can use to measure, then it is called a quantity or a physical quantity. So a physical quantity, it is a quantity that can be measured. It is expressed by a magnitude with a suitable unit. So when you measure something, it needs to have a magnitude. What we mean by magnitude is that it needs to have a size. And after you have measured and it has a size, there should be a unit. Either it's in kg, centimeter. What we are saying is that when we talk about a physical quantity, it is a quantity that can be measured, and it is expressed by a magnitude, which is the size, and it's supposed to have a unit. So now, since this definition of a physical quantity, it was able to give us this term which we call magnitude, then we want to define what a magnitude is. So a magnitude, so we say that magnitude is the size of a quantity. Is the size of a quantity. For example, you can say 2, 150, okay, 3 or 10. So it's just a size. That's what we mean by magnitude. It's just a size. Okay, so now this definition of physical quantity brought to attention the word magnitude and also a suitable unit. So now, since we have defined magnitude, we now want to define a unit. We want to define a unit. So when you talk about a unit, is the standard. So it is the standard measure of a quantity. Standard measure of a quantity. It is a standard measure of a quantity. So it's a standard measure of a quantity. For example, we can say we can have AC, which is seconds. Okay, then also we can say meters, m, which is a meter. Okay, then also we can say kg, which is kilograms. Okay, that's what we are meaning here. That's about the unit. So now we look at types of physical quantities. So types of physical quantities. So we now look at, okay, we now look at types of physical quantities. So number one, we have what we call base quantity. Okay, So what we mean by base quantities, you say these are fundamental physical quantities. These are fundamental. These are fundamental physical quantities. These are fundamental physical quantities. Actually, the other word for base quantities, we call them fundamental quantities. Okay, so they are just fundamental, just that's the way they are. So what are base quantities? So these are fundamental physical quantities. Okay, these are fundamental physical quantities. Okay, so the other thing that you should know about base quantities is that these quantities have one unity only. So they contain one unity only. So another point to note when we talk about basic quantities is that there are 7. So there are 7 physical. There are 7 physical quantities. So there are 7 physical quantities. So the table 1.2 is showing base quantities, base unit, if you like, base units and symbols. So base quantities or fundamental quantities, they are 7, like we said earlier on. So we have length, we have time, we have mass, we have temperature, we have amount of substance, and we also have light intensity. So you have to know the 7 of them. So if you don't know the 7 of them, then you just know about, let's say, 75% what makes up the base quantity. So therefore, now we're going to talk about the base units. We have said that physical quantities, these are quantities that can be measured. They have a magnitude and the unit. So those physical quantities can be divided into what we call base quantities and the derived quantity. So now we are looking at first on the what we call base quantities, which we said that there are 7. Okay, so length is measured in meters. Okay, then the symbol is small letter m. Then time is measured in seconds, so use small letter s. Mass is measured in kilograms, symbol kg. Temperature, that's Kelvin. Then we have this K. Amount of substance, which is mole. Then just remove the E, that's a symbol. And we'll find this in chemistry when we'll be looking at number of moles. This is what we'll be using actually. Then light intensity, candela, which is CD. So we said that base quantities, they only contain 1 unit. They only contain 1 unit. You never find them to say meters per second. No, these are 2 units. Meters and seconds, these are 2 units. So that is not a base quantity. So if you find something like meter per second, so meter per second squared, those are what we call derived quantities. These are what we call derived quantities, but we have not yet reached there. But it is these base quantities that are able to form derived quantities. Okay, so let's now dive in to look at what we call as derived quantities. Okay, so now we look at derived quantities. So now we look at what we call derived quantities. So these are quantities that consist of two or more base. So what we mean by derived quantities, we are saying these are quantities that that consist of two or more base quantities. Okay, therefore they have a combination of units. So for example, speed is a derived quantity. Speed is the total distance per unit time. Therefore, it consists of two basic quantities, which is length and time. Okay, so we are saying speed is equal to distance over time. And we know that, but we know that distance is the same as length. So we are saying that derived quantities, these are quantities that consist of two or more base quantities. And we know that base quantities, there are only 7 of them. But if you combine those two, we're going to have what we call derived quantity. And in short, what we were just saying is any unity, any quantity, any physical quantity that is not among the 7 base quantities, then it is going to be deemed to be a derived quantity. Okay, let me give you another example. Let me talk about weight. Weight is a physical quantity. Now, is it among the 7 that are deemed to be derived base quantities? No. So therefore it will be called a derived quantity. That's a trick that you should know there. Okay. Okay, so we now look at derived quantities as well as derived units and symbols. This is the table that shows that. So area is square meter. So area is measured in a square meter, so which is square meters m squared there. Then volume is cubic meter. So this is where we learn to understand that it's not meter cubic, it's cubic meter, so that we don't make those mistakes. No, meter cubic, cubic centimeter cubic. No, we don't say that. The square meter, cubic meter. Okay, then velocity is measured in meter per second squared, meter per second squared. And then density, it is kilogram per cubic meter, kilogram per cubic meter. So now that's why we are saying that when we talk about derived quantities, we are saying it's a combination of units. It's a combination of units. It's not one. Okay, so like for here we are saying square meter, there are 2 m's. It's not just one. If it's only one, that is going to be now a base quantity, and that is going to be deemed as length. Okay, that one is going to be deemed as length. But if you square it, then it's a combination of 2 units, so it now becomes a derived. Okay, so Newton, yes, one will say you have written one symbol there, but there's a derived unit again for Newton, which is we can say kgm slash squared, kg meter per second squared. We'll look at those when you start deriving, when you start looking at force, how to from the second law formula, which is force is equal to mass times acceleration. That's where all that comes about. Okay, so then pressure is measured in Pascal, which is PA. Energy measured in joules, which is J. Then power is measured in watt, which is watt. So which is W, capital letter W. Okay, so let me make mention that any physical quantity that is not among the 7 which we call the base quantities, it is going to be deemed as a derived quantity. So weight, all those are deemed as derived quantities. Okay, so that's about that. So let's try to get back to the table of base quantities. Actually, we omitted one. We missed out one, which was current. So current is measured in ampere, which is going to be capital letter A. So now we can see that they are now 7. Okay, so those were voltage, what those are not base quantities but derived quantities. So that's about that. So we've looked at base quantities tables, then we also looked at the derived quantities. Actually, let me even bring it this way. We looked at measurement. We talked about that physics deals with physical quantities and motion of matter. Then it brought to our attention, we started talking about what we call a physical quantity. That is a quantity that can be measured and it can be expressed by a magnitude with a suitable unit. So what we mean by magnitude is a size of a quantity. For example, 2, 150, 3, 10. Okay, then it also brought to our attention that in the definition of physical quantity there was a suitable unit. So a unit is a standardized measure of a quantity. So for example, seconds, meter, kilograms, and so on and so forth. Then from there we now look at types of physical quantities. So number 1, we have a base quantity, and number 2, we have a derived quantity. And we say that the base quantity, these are fundamental physical quantities. They're just fundamental, just the way they are very important, because they're able to formulate what we call derived units or derived quantities. So we can say that these quantities have one unit only. Please get that point clear. They have one unit only. They are 7 physical quantities. These are the ones. We have this is 1, 2, 3, 4, 5, 6, 7. So these are the basic or base quantities of our fundamental quantities. So now these are what we call base units. So if you're asked to say, can you list at least 4 base units, please remember to talk of meter, second, kilogram, Kelvin, mole, and candela. Then the symbols, these are the ones that are here. Okay, then we want to talk about what we call derived quantities. These are quantities that consist of 2 or more base quantities. If you put them together, if you put those base quantities together, whether you multiply them or you divide them, they are going to produce what we call a derived quantity. Okay, so that's what we are saying. So we're going to do this. So therefore they have a combination of units. For example, speed is a derived quantity. Speed is equal to distance over time, and we know that d is equal to L, which is length. Okay, so for example, volume is equal to L times B times H. All these are length. Okay, so you are multiplying length. Okay, so volume is a derived quantity. Okay, so this was a table that was showing the derived quantity and derived units as well as symbols. So otherwise, let's look at one example here and see what we can do with that. Okay, then question 2, they are telling us, say, write down the derived units for A, area, B, Newton, C, watt, and D, joule. Okay, so let's start. So we'll say solutions. So we write the solutions. Okay, so we write solutions. Okay, so we'll write solution. So for question 1a, the answer is identify whether the following are base units or derived units. So this one, meter, this is a base unit. That's a base unit. Okay, not two ways about it. Then B, that's CD, that's candela, that's a base unit. Then square meter, that is C, that is a derived unit. That's a derived unit. Then D, mole, that's a base unit. Then E, Pascal, that's a derived unit. So these are the solutions for part A or question 1. These are the solutions. So now we go to question 2. Write down the derived units for area. So the derived unit for area, it is square meter. It is a square meter. Now this was for A. Now we go to B. B, it was interesting. They were telling us for Newton, write down the derived units for Newton. Okay, so I told you that we'll do it this way. From the second law of Sir Isaac Newton, we say force is equal to mass times acceleration. So we know that all this is supposed to be measured in what, in Newton. Now we want to find the derived unit for a Newton. So we'll say that mass is measured in kg, then acceleration is meter per second squared, which is acceleration due to, so acceleration, which is A, it is meter per second what, squared. Let me put it this way. Let me even put it this way. So kg, I'll put a dot for multiplication, then meter per second squared. Now remember that this m here is on top, then this one is at the bottom. So you multiply kg times m, it will give us kgm slash s squared. Or if you like, you can say kgm s negative 2. If you remove this slash, then this becomes a, it will have a negative. Okay, so this is the answer here. Okay, this is the answer here. Okay, so you can choose N for this one or that one. So that is for B. So for us, you know what we say that let me start with D for you to understand A. Let me start with D first for you to understand E. For you to understand C, let me start with D. Okay, so Joe, that is the work. So work is equal to force times distance. Okay, so now let's do this. Where then we have said that force is kgm slash s squared. Remember what we did from what we are just from doing here under Newton. So we're going to, where there is force, we're going to put this. So it will be kg m slash s squared multiplied by distance is measured in meters. So you can see that this m and this m, they are on top. This s squared is at the bottom. So if you multiply, it will be kg m squared slash s squared, or you can say kg m squared s negative 2. This is the answer here. That is the answer. So now for you to understand C, now we're going to do this. What, that is power. Power is equal to work over time. Therefore, where this is for work, so where there is work, I'll substitute this guy here. So I'll put kg m squared slash s squared, right, divided by s. This is time. Time is measured in seconds. So time is measured in what? In seconds. Let me put a small s there. Okay, so now mathematically this is going to be kg m squared divided by, this is what I'm saying, divided by s squared divided by this divided by s. So therefore mathematically we say that kg m squared over s squared times, it will be reciprocal now, 1 over s. So if I multiply this on top, it is going to be kg m squared, okay, by 1, it will be this, over or slash s times s squared square second multiplied by s, it will be like this. So that is the answer there. So that's where we end here for the first lesson on measurement. So the next lesson that we are going to look at will be what we call the metric prefix. So we'll look at metric prefix. That is what we are going to look at when we meet, when you say multiples and sub-multiples of units. That is what we are going to look at when, you know, a scientist was able to encounter some very big numbers and very small numbers. Let's say, for example, you're calculating for force and you say you got 99208421890 as your answer. Then you say force is equal to that number Newton. No, this number is very, very big. You can do something. You know what to do. So that will be the other lesson that we're going to look at, is about metric prefix. So otherwise, that's where we end here.